Hello and welcome back to College Algebra, Math 121. This is a video over section 4.4, and what we're going to be doing is we're going to be solving exponential and logarithmic equations, okay? And this is really the reason why we have logarithms is to help us solve for exponents. So let's write this down up here, okay? And let's write small. And what I want you to write is that logarithms help us solve for exponents, okay? All right, that's the big takeaway of what a logarithm does, okay? And so what I want to do is talk about a couple things, all right? Let's just, we have that information there. Let's talk about exponential equations, okay? Exponential equations. All right, and what I want to do is this, okay? Let's just think of a couple of examples to help us see how we solve exponential equations, all right? And so what I can do is this. Let's say I have, 2 to the what power gives me 8, okay? And if we're given this equation, all we have to do is think about it, because we're asking ourselves, okay, 2 raised to the what power gives us 8, all right? And that answer would be 3, okay? And so x would be 3. Okay, and another way you could do this, instead of thinking about it, is by taking 2 to the x and taking 8 rather, and rewriting that as 2 to the third power, okay? Now what we have here is that when the bases, okay, when the bases are the same, so when the bases are the same, okay, then you can set the exponents equal to each other, okay? Okay, exponents equal to each other. All right, and so that's kind of nice when you have numbers like this, okay? And let's, take a look at another example, all right? And that allows us, let me do this, where you have x and 3, and so x is equal to 3, okay? And that's how you can solve those, okay? So oftentimes what we want to do with various exponential equations is rewrite the base, okay? So let's call this rewrite the base, okay, to have the same bases, okay? And let's just think of something else. Let's do like, all right, and let's think of another example. Let's think of something like this. And let's do an example here. And let's say, 7 to the what power gives us 49. Okay, and that's pretty easy to think about. You already know that the answer of x is going to be 2, okay? But, if we rewrite the base and rewrite 49 as 7 squared, because our bases are the same, all right, then we can set our exponents equal to each other. We just get x equals 2, okay? Now, let's think of something else, all right? Let's extend this idea here, all right? Let's take a number like, say 49 to the what power gives us 343, okay? Now, what I notice about these numbers is that these numbers, 49 can be rewritten as 7 squared, okay? And so let's rewrite 7 squared raised to the x power. And then 343, that's actually the same thing as writing 7 to the third power, okay? And so now what we can do is take a look at this, and we can simplify this over here using our rules of exponents. When I have an exponent raised to another exponent, then what I'm going to do is I'm going to multiply my exponents, and I'm going to get 7 to the 2x power is equal to 7 to the third power, okay? Now, all I've done is take what we had here and rewrite it to have a common base. Now that my bases are common, okay, 7 and 7 are common, I can set my exponents equal to each other, all right? And now I have the equation 2x is equal to 3. Divide by 2, and all of a sudden my exponent is equal to 3 halves. Now, here's the deal. On a lot of these problems up here, all right, you were able to just think about them and do them, all right? On something like this, you're going, all right, wait a second here. I can't necessarily just automatically think about that. I have to manipulate this a little bit, okay? And that's something that you may have to do, all right? So now let's think about a third option, okay? And I like to do, I like to do this, all right? Here's our third option. And let's think of a couple of examples. Let's do 3 to the what power gives us 9. Okay, I'm going to do a couple of these. Let's do 4 to the what power gives us 16. 4 to the what power gives us 64. Okay, 2 to the what power gives us 16. Okay, on all these, we can just think about them and solve, okay? You can just say, all right, x is equal to 2 here, x equals 2 here, x is going to be 3 because 4 to the x is equal to 4 to the cubed power. 64 is 4 cubed. 2 to the x is going to be x equals 4, okay? Now, all right, so these, we could do these, so all of these we could do very easily, okay? All right, by thinking. All right, and that's primarily what you're doing oftentimes when you're trying to solve something like this, okay? You're thinking about it and you're like, all right, how do I do this? Okay, but now what about, so now, all right, what about, say 4 to the what power gives us 4.732. Okay, how do you solve that equation? X is equal to what? Okay, and so what we do now is we can do a number of things, okay? And that's what we're going to, use these types of equations and use logarithms. So to solve this equation, okay, so to solve, you must use a logarithm, okay? And that's why we have logarithms, is to solve equations like this, okay? So 4 to the what power is going to give us 4.732, and you're like, well, crap, I don't know. That's kind of a hard one, all right? So what I want to do is actually solve this in two ways. What was that number, 4.732? Okay, so let's do this, all right? So example, 4 to the what power gives us 4.732. Okay, here's method 1, okay? Method 1. All right, if I'm going to take 4 to the x power is equal to 4.732, number one, we need to put this into log form, okay? And so what I'm going to do is I'm going to do log base 4 of 4.732 and set that equal to x, okay? And that's the first way that we could solve this, by using a log. And remember, guys, that this is a number, okay? And this is an exact number. Okay, the exponent is this value here, log base 4 of 4.732. Okay, now if I plug this into the calculator and do change of base, okay, we can do that and we can get a decimal approximation. So what we can do is we can get x is equal to log of 4.732 divided by log of 4. Okay, so let's do that. All right, and so we can do log of 4.732, okay, and then divide that by log of 4, and we're going to get that x is approximately 1.121. So 1.121, all right? And this is an approximate value, okay? And oftentimes what we'll have you guys do is, is to take this and, or, solve it using this, but, do find a decimal approximation, okay? And we'll round to 2 or 3 decimal places. Okay, now let's do a second method, okay? And I don't care which one you guys do. Typically I do method 2 when I'm solving, but it kind of depends on the problem, okay? So if I have 4 to the x power is equal to 4.732, one of the things that I can do is I can apply the natural log to both sides, okay? So I would do this. I would introduce a natural log. And if I do it to one side, natural log of 4 to the x, okay, I would need to do it to the other side. So natural log of 4.732. All right. Now, the reason why I'm doing this is because what this allows me to do in this point here, using our rules of logarithms that I know, I have an exponent of x. And when I apply the natural log to both sides, what I can do is I can take this x and I can bring it out front as a multiplier. So now I can write my equation as x times the natural log of 4, okay? The x is gone, the x is out front now, okay? And then that's going to equal the natural log of 4.732, okay? Now what I can do is I can now divide both sides by the natural log of 4 and do the same thing over here, all right, and do the natural log of 4. These parts here are going to divide out, and you are left with that x is equal to the natural log of 4.732 divided by the natural log of 4. Okay, now what you should notice is that this is pretty much the same thing that we had over here, okay? And if we use the natural log portion on our graphing calculator, so natural log of 4.732, okay, and then divide that by the natural log of 4, all right, we're going to get the same thing. We're going to get that x is equal to, or x is approximately, okay, 1.121, all right? So it doesn't matter which way you do it, but it just depends on how you want to rewrite this. There are times when you will want to use method 2 versus method 1. However, you can do them at any point, okay? But I'm simply just showing you guys that this is something that you can do, all right? So that's that, all right? And that's how we solve these types of equations, okay? Now let's talk about solving logarithmic equations, okay? All right, so let's do solving logarithmic equations, okay? And let's just think of an example real quick. And let's just do, log base 3 of x is equal to, I don't know, let's just do 4, okay? Now, how you would solve this, and the difference is that your variable is inside of your logarithm, okay? And what you'd want to do is this. You'd simply just want to rewrite this as an exponential function, okay? And you would take your 3, 4 becomes the exponent, the log falls down into the abyss, much like how Elsa falls into the abyss, and you get that x is equal to 3 to the 4th power, and you can just evaluate that as is. So 3 to the 4th power would give us 81. So x would equal 81, and that's our answer, okay? Now these can get a little trickier, all right? And we can, let's say we have something like this, where you've got, say, log base 2 of x plus 7 is equal to, say, 3, okay? And so if you were solving this equation for x, again, you would take this and you would put this into exponential form. The log falls down into the abyss. 2 becomes your base, 3 is your exponent, and you're left with x plus 7. And you just solve that equation from there. All right, 2 cubed would give us 8. All right, x plus 7, so then you'd subtract 7 from both sides, and you just get that x is equal to 1. All right, so that's that. All right, let's come up over here, and let's do another example. And this one we're going to use a natural log. So let's just say you've got an equation like 2 times the natural log of 5x is equal to, say, 7. Let's not do 7, let's do 8. Okay. And so one of the things I want to do, given something like this, a natural log equation, and you're solving for a variable that's inside of your natural log, is you'd want to first isolate your log. Okay, you want to get a log by itself. So I'd want to divide by 2 on both sides. So I'd get the natural log of 5x is equal to 4. Okay, so I've isolated that. Now, one of the things that you could do, you can do this doing 2 methods. Okay, so let's do this using method 1. Okay, and then we'll do it using method 2. Okay, and one of the ways that I would do this, and I would, when I'm doing this, I always use method 1. Okay, and methods 2, like method 1 is easy for me to explain. Method 2 is difficult for me to explain, and method 1 it makes sense. Method 2, it makes sense, but not as well as method 1. But I'm going to show you both. Okay, method 1 is this. I would rewrite this as a log, as a natural log. Okay, I would write it as log base e of 5x is equal to 4. Okay, that's the first thing I would do. And what I would do is then I would take this and turn it into exponential form. Okay, so the log falls out, e is my base, 4 is my exponent, so e to the 4th power, and you're left simply with 5x, okay? And then you can divide by 5 on both sides, okay? And then you just get that x is equal to e to the 4th over 5, all right? And that's the, and this is your exact answer, okay? This is exact. Now, you can evaluate this. You can plug this into your calculator, and I gotta find the E button. Okay, and when you plug this into your calculator, you just plug it in how you see it. There is an E button on your calculator, and so you would get that x is approximately, okay, 10.919. 10.919, okay? And this is an approximate. Okay. Now we can do the same thing. Find the same solution using another method. Okay. So if we have the natural log of 5x is equal to 4, one of the things that we can do is put, much like how we applied the natural log to both sides on the other one, you can apply an e to both sides and make everything an exponent. Okay, so check this out. So I'm going to do e to the natural log of 5x power. And then that's going to equal e to the 4th. Okay, this is one thing that you can do. Now, here's the deal. Simplifying this, what you have to understand is that e and natural logs think about it. A logarithm solves for an exponent. It's an inverse operation. So when you have a log inside of your exponent, what it does is it undoes your exponent, and you're simply just left with 5x is equal to e to the 4th power. Okay? And then you would just divide both sides by 5, and you'd get the same thing, that x is equal to e to the 4th over 5, okay? That does work. I don't normally do that because I get this idea here, but I get this idea much, much better than I do this one over here. Either one works, okay? But this one, there's no, mathematical way except for saying they're inverses of each other. Trust me. I sat there and I grilled every pre-calc and calc teacher. When I was teaching calculus, I would go, how does this happen? show me why this works. And they couldn't. The only way that you can say it is that they're inverses of each other, so they undo each other, and so you're just simply just left with what you have, which is 5x, okay? So unfortunately, I can't explain to you why this works except for the fact that they're inverses of each other, and inverses undo itself, okay? I like this idea much, much better because this is something that makes sense to me, okay? However, this does work as well, all right? So whatever works for you works for you, okay? So now what I want to do is go through some more of these practice problems, okay? I wanted you guys to just see, you know, how we solve exponential equations and how we solve logarithmic equations, okay? And there are other types, and I want to go through that because they're practice problems inside of the, you know, in the rest of the notes. So let's continue on with a lot of these practice problems, and let's go ahead and solve, okay? So if I'm solving this, you know, first of all, you have to recognize that this is an exponential equation, okay? I have 5 to the 3x minus 6 power is equal to 125, all right? Now, could you solve this using a logarithm? Yes, you can. However, you should realize that 5 and 125 are related, okay? And I could rewrite, let me rewrite 5 to the 3x minus 6 power. That whole expression is your exponent, okay? And that would be equal to 125. I'm going to rewrite that as 5 to the third power, okay? So if I rewrite those, I have the same base, so I can set my exponents equal to each other. So I can write the equation 3x minus 6 is equal to 3. All right, I'm going to add 6 to both sides. I get 3x is equal to 9. I'm going to divide both sides by 3, and I get x is equal to 3. Okay, and that's that. Okay, so rewriting that makes it a lot simpler. You're not dealing with any logs. So if you don't have to deal with logs, I wouldn't. Okay, that's not something, you know, not a road you necessarily want to go down. But if you have to, we need to. All right. Over here, I have 8 to the. So now notice what I have. Notice that I have an exponent or a variable as an exponent here and here. Okay. So this one's a little tricky. What I have to do here is I notice I have 8 and 4, okay? Now, 8 is, I could rewrite 8 as 2 cubed. And I'm going to raise that whole thing to the x plus 2 power. And that's going to equal, I'm going to rewrite 4 as 2 squared. And I'm going to raise that to the x minus 3 power. Now, remember by using our rule of exponents that when I rewrite this, I can multiply my exponents. If I have an exponent raised to another exponent, I multiply. But because this is a quantity, x plus 2, I have to distribute. So here's what I get. I'm going to show a lot of steps here, but I'm going to rewrite this as 2 to the 3 times x plus 2 power is equal to 2 to the 2 times x minus 3 power. All right, and what I would need to do is distribute my 3 here, and so that's going to give me 2 to the 3x plus 6 power, and I get 2 to the, distribute my 2, we're going to get 2x minus 6, all right? So now, now that I've rewritten this, I have a common base, okay? Now I can set my exponents equal to each other, all right? So I'm going to set up the equation, 3x plus 6 is equal to 2x minus 6, all right? Now from here, I'm going to subtract 6 from both sides, and so I get 3x is equal to 2x minus 12. I'm going to subtract 2x from both sides, all right? And so here I get that x is going to equal negative 12, and that's my answer, okay? And so that's how you do those. So you want to just, you know, and all I'm doing, especially on this one, you have to recognize. This one you could use logarithms. This one you have to use, you have to change your base, okay? You have to rewrite your base, all right? To do that. All right, so now let's do this. Let's do, on these questions, it wants us to find the solution set and then use a calculator to obtain a decimal approximation to 2 decimal places for the solution. So these are questions that we don't have answers for, okay? Remember 5 to the third power here would be 125, and so 5 to the what power gives you 134. This I can't necessarily do, and I can't change this base to rewrite it as 5 to some power, Okay, so this is something you have to recognize. And so let's do this. Let's, let's do, doesn't matter which method we do, but I'm just going to do the first one. I'm going to rewrite this as log base 5 of 134 is equal to x. Okay, so this is my solution set. Okay, that's my exact answer. But we want to find a decimal approximation. So log of 134 divided by log of 5. All right, and let's plug that into the calculator. And that would give us that x is approximately 3.04. Okay. Now again, you could do this another way. You could do this with the natural log. So you could apply the natural log to both sides. Just depends on how you see it. I'm going to bring my x out front. So I have x times the natural log of 5, and that's equal to the natural log of 134. Divide both sides by the natural log of 5, divide by the natural log of 5, and we would get the same thing, that x is approximately 3.04. Okay, so it doesn't matter how you do it, just kind of depends. All right, I'm going to do the natural log one. I kind of like that one. So I got natural log of 10 to the x equals the natural log of 8,000. And so I'm going to bring my x out front. So I have x times the natural log of 10 is equal to the natural log of 8,000. Divide by ln of 10. Okay, divide by ln of 10. And so then we get that x is equal to, plug this into the calculator, natural log of 8,000 divided by the natural log of 10. And that's going to give me 3.903. So first of all, here's my exact answer. X is equal to natural log of 8,000 divided by the natural log of 10. Okay, and then x is approximately 3.9. Okay, and that's what we got. All right. All right. So now you got something like this. All right. You have this exponential equation. Same thing, we want to find an exact answer, but let's find a decimal approximation for it as well. Now, again, what I want to do, whenever I have this, I want to isolate my exponential value. Okay, so I'm going to move all my other numbers over. So I would add 5 to both sides. Okay, so I would get 7 times e to the 2x is equal to 63. And then I would divide both sides by 7. Okay, 7's divide out here, and you are left with e to the 2x is equal to 63 over 7, which is 9. Okay, so now, and we can do this a couple different ways. We didn't go over an example like this, but let's solve this 2 ways. Okay, first way I'm going to solve this is I'm going to rewrite this as log base e of 9, okay, is equal to 2x. All right. When I have log base e, remember that's just simply a natural log of 9, and that's going to equal 2x. I'm going to divide both sides by 2. And so then I get this solution that x is just equal to the natural log of 9 divided by 2, okay? This is exact, okay? But the thing that you have to understand is that, if you write log base e, you do want to change that into a natural log, okay? So that's your exact answer. Let's plug that in the calculator, natural log of 9, and then divide it by 2. And that's going to give us an x value, that x is approximately 1.1 basically, okay? And that's that, all right? Now what I want to do, I'm going to do this using another method. So this is method 2, okay? This is method 1, okay? Method 1, all right? So you got options here. So I'm going to do e to the 2x, all right, is equal to 9. All right, and what I'm going to do is I'm going to apply the natural log to both sides, okay? So if I apply the natural log of e to the 2x, okay, is equal to the natural log of 9. Okay, now we'll get the same answer, all right, but just getting it a different way. what we can do is we can bring out this 2x and bring it out as a multiplier out front. So 2x, okay, times the natural log of e is equal to the natural log of 9. Now remember something, okay? The reason why this works, and I prefer method 2 on this one, the reason why this one works is that the natural log of e is equal to 1, okay? Remember, all right, if you think about the natural log of e, that's just log base e of e, okay, is equal to some number x. Okay, if you change this into exponential form, the log drops off, you get e is equal to e to the what power. Okay, e to the what power gives you e, so x is just equal to 1. That's why you just get 1 here. So when you do this, okay, and that's what's nice about applying the natural log to both sides, is that especially for an equation where you have e as your base, you would want to do that, all right? And the reason why is because the natural log of e just becomes 1. So you have 2x, okay, 2x times 1 is equal to the natural log of 9. All right, 2x times 1 is just 2x equals the natural log of 9. Okay, divide by 2, divide by 2. And so you get the same thing, that x is equal to the natural log of 9 over 2, and that x is approximately 1.1. All right, so it kind of just depends on, how you see that. All right, so, with this, either method is fine. Doesn't matter to me, but you do want to make sure that your answers do have a natural log in them. Okay. All right, let's take a look at the next page. Okay, on this next one, remember how I told you that you couldn't do these problems without changing the base? Well, I lied. Okay, you can. All right, and here's what we have to do. What I'm going to do, and this one does require us to do the natural log. So, I can't change my base here, all right? But what I can do is I can apply the natural log to both sides. And so natural log of 3 to the 2x minus 1 power is equal to the natural log of 7 to the x plus 1 power. So what I want to do is take my exponents and bring these out front and get rid of them as exponents. Okay, so I'm going to do this. I've got 2x minus 1, all right, times the natural log of 3 is equal to x plus 1 times the natural log of 7. Now this is where it gets a little weird, okay, and what I'm going to do is we're trying to isolate our x value. Now in order to do that, what I want to do is I do want to distribute my natural log of 3, okay. So watch what I'm going to get here, okay. I'm going to get 2 times x times the natural log of 3 minus the natural log of 3. And that's going to equal, do the same thing here, distribute my natural log of 7. So I get x times the natural log of 7 plus the natural log of 7. This is a tricky problem, okay? So bear with me, all right? What I'm going to do next is I'm going to move my terms with an x, okay? So here and here, I'm going to get those on the same side, and everything else get on the other side. So what I'm going to do is I'm going to subtract x times ln of 7 from both sides, so minus x times ln of 7, and I'm going to add the natural log of 3 to both sides. Okay? Now, so what I'm going to get here is I'm going to get 2x times the natural log of 3, all right, minus the natural log, x times the natural log of 7. Okay, and that's going to equal the natural log of 7 plus the natural log of 3. Now what I can do here, all right, and this is where it gets a little weird, is I can factor out an x from this left side. Okay, so if I factor out an x, then I'm left with 2 times the natural log of 3 minus the natural log of 7. Okay, and that's going to equal the natural log of 7 plus the natural log of 3. All right, and then I'm going to divide 2 ln 3 minus the natural log of 7, that whole quantity, okay, divide by 2 natural log of 3 minus the natural log of 7 from both sides. So here's what I get. I get that x is equal to the natural log of 7 plus the natural log of 3 all over 2 times the natural log of 3 minus the natural log of 7. Yuck. Okay, that's our value. Okay, but what I want to do is plug that into the calculator. Okay, and what that's going to give us, all right, this is your exact answer, okay, but your approximate answer would be 12.11, okay, and this is your approximate. All right, that one's really tricky. That one you'd want to practice that and put yourself through those types of scenarios, okay? All right, on the next one, okay, we want to solve this equation, e to the 2x minus 8 times e to the x plus 7 equals 0. Wait a minute, this looks like a quadratic. Okay, so what I'm going to do is I'm going to factor this, all right? And you can think of it like this. You could do a u substitution. You could let u equal e to the x. So really you have u squared minus 8u plus 7 equals 0. All right, and let's factor that. So that's just going to give us u minus 7 times u minus 1, okay, is equal to 0. So now what we have, let's just plug our e to the x back in. That's e to the x minus 7 times e to the x minus 1, and that's going to equal 0. All right, so now that we've factored that quadratic, okay, we have e to the x minus 7 equals 0. Okay, and we've got e to the x minus 1 equals 0. Okay, so let's do this. Let's solve these equations. So let's add 7 to both sides. Okay, if I've got e to the x is equal to 7, all right, I'm going to apply the natural log to both sides. All right, bring my x out front. So I've got x times the natural log of e is equal to the natural log of 7. All right, natural log of e just becomes 1, so we get x is equal to the natural log of 7. Okay, that's my exact answer. To evaluate that, we would get that x is approximately 1.95. Okay, that's one of our answers. All right, now over here, let's do the same thing. Let's go ahead and add 1 to both sides. All right, so then I get e to the x is equal to 1. Let's apply the natural log to both sides. Equals the natural log of 1. Okay, now same thing, bring your x out front. So x times the natural log of e is equal to the natural log of 1. Natural log of e is just 1, so x is equal to the natural log of 1. Now, plug that into your calculator, natural log of 1, and whoa! X equals 0. So that brings us to another point. Okay, what the natural log of 1? Okay, what is that? So if I have the natural log of 1, why is that equal to 0? Okay, let's think about that. Log base e of 1 equals 0. Well, think about it. Put this into exponential form. All right, the log drops down. 1 is equal to e to the 0 power. Anything raised to the 0 power gives us 1. Okay, and that's how we get that. All right, moving on. Let's talk about these log equations. Let's go ahead and solve these. So we're switching it up, going from solving log equations now. And so what I want to do here is I'm going to take my 2, bring that underneath, make my 2 my base, 3 is my exponent, and we're left with x minus 4. So x minus 4 is equal to 8. Add 4 to both sides. And we get that x is equal to 12. Ooh, that was nice and easy. Okay, now let's do this. All right, let's solve this one. Divide by 4 on both sides. Isolate the natural log. So I've got the natural log of 3x is equal to 2. Okay, remember, you can do this a couple different ways. I'm going to change this to log base e of 3x is equal to 2. Okay, I'm going to take e, that's my base. 2 is my exponent, so e squared. The log drops off, and we're left with 3x. Divide by 3, divide by 3. So then x is equal to e squared over 3. So if we type that in, e squared divided by 3 is going to give us that x. So this is our exact answer, okay? And then that x is approximately 2.46. All right, and that's the idea. All right, next one. Now, we didn't talk necessarily about this one, or these types, but what I have here on this is I have multiple logarithms, okay? What we want to do is get one logarithm. So remember in the last section how we expanded and condensed our logarithms? Well, we're going to do that here, okay? And since we're adding our logarithm, okay, adding our logarithms, we want to multiply what we have. So what I'm going to do is this. We're going to get log of x times x minus 3 is equal to 1. Now, when I write that, this has a base of 10, all right? So if we don't have a base, it's a base 10. So log base 10, and let's distribute our x here, of x squared minus 3x is equal to 1. At this point, what I want to do is turn this into an exponential form. All right, so my 10 is my base, 1 is my exponent, the log drops off. So now we're left with x squared minus 3x is equal to 10 to the first power. Okay, now let's move this up over here and solve. So we've got x squared minus 3x is equal to 10. All right, I'm going to move my 10 over. X squared minus 3x minus 10 is equal to 0. Now we have a quadratic, okay, and we can solve that quadratic. So what I'm going to do is I'm going to do x minus 5 times x plus 2 is equal to 0. All right, so I'm going to set each of my values equal to 0. So x minus 5 equals 0, x plus 2 equals 0. I'm going to add 5 to both sides, okay, and we get that x is equal to 5, and then subtract 2 from both sides, and so I get that x is equal to negative 2. But wait a second. Think back to your original equation. Remember something. Remember that you can't take the log, so you can't take the log of a negative number. Okay? Therefore, you have to check. All right? So you must check. Negative 2 doesn't work. Okay? So our solutions in this case are going to be that x is equal to 5 and that x equals negative 2 is extraneous. Okay, we can't plug in negative 2 because that would make this undefined. Okay, and that's the idea. All right, so let's do this. Let's go ahead and solve this next one. And this one's going to be pretty tricky. But the first thing I want to do is do this. Let's do, we can do this probably a couple different ways. Let's combine these two logs. All right, so I'm going to do log of x minus 3 is equal to the natural log of 7x minus 23 over x plus 1, okay? Now, when these logs are equal, okay, and here's kind of this interesting thing, all right? I have the natural log, and the natural log of something is equal to something else. So what I can do is I can take what's inside of my natural log and set those equal to each other. And so all I'm going to do at this point is write out the equation x minus 3 is equal to 7x minus 23 over x plus 1. Not too bad, okay? And so now we've gotten rid of the logs, and we just need to solve. So what I'm going to do is I'm going to multiply both sides by x plus 1. Okay, multiply this by x plus 1. All right, these are going to divide out. Let's multiply this guy out. That's going to give us x squared plus x minus 3x minus 3 is equal to 7x minus 23. All right, combine your like terms. X squared minus 2x minus 3 is equal to 7x minus 23. All right, now I'm going to subtract 7x from both sides. Okay, add 23 to both sides. So now check out what I get, guys. All right, I'm going to get x squared minus 9x plus 20 is equal to 0. So now I can factor this, and I've got x minus 4 times x minus 5 is equal to 0. And then I've got set each of these equal to 0. So x minus 4 equals 0. Set x minus 5 equal to 0. So x is going to equal positive 4. Okay. Here, x is going to equal positive 5. And that's my answer. Okay. Now, both of these would work because they wouldn't make my logs negative. So those are my solutions. So a lot going on. I know this is a really long video, but there's a lot of information on it. We're going to go ahead and skip that last page, and we're going to just going to start our homework. So I hope you enjoyed this video. See you in a bit. Talk to you later. Bye!